Okay, so we're going to be talking about probability, and we're going to think about what probability is. And I'm going to try and use examples that that we've all seen, and we can all kind of understand the usual examples that we have, like what is the probability of getting a heads if you flip a coin? We're going to be doing those kinds of things. But first, we're going to try and comprehend what probability actually does. Now, let me ask this question. Give me a yes or no in the chat. How many of you guys know what the stock market is? Yes or no? I'm going to write that word down and just see if you know what the stock market is, or if you've ever heard of the JSE. Any of these two things. Okay, I'm seeing quite a few yeses, quite a few no's. Lunico says he's heard of it, but doesn't exactly know what it is. All right, so here's what happens most of the time. Now, when we have a company, let's say, for instance, Princess says, I know the stock market from reading comics. I don't think it's quite the same stock market that we're talking about. Mfundo, you're almost there, kind of like FNB. Okay, so what normally happens is when we have a company, let's say, for instance, Apple. Let's take Apple. Right, and I don't mean like Apple the fruit. I mean like Apple, your iPhones and your iPads and your MacBooks and your Apple TVs, that company. Right. Now, when Apple started, any of you who know who started Apple, you'll know that a very old man, I think he's actually passed away now. Yes, he did. He passed away a couple of years ago. His name was Steve Jobs. Now, Steve Jobs started Apple in his garage. Okay. It was just a small company. He was designing things like computers, a small company. Right. I am Steve Jobs. Yes, there's a movie called I Am Steve Jobs. Okay, so when he started this company, it was just a small company in a garage. Now, in order for him to grow this company, he came across a couple of investors, and they gave him a lot of money to turn Apple into what it is today. And that worked out for a while, until about the 1980s, right? 1980s to the 1990s, people were buying stocks in his company, and he was able to buy these stocks. But in order for Apple to go global, and I mean so that you and I can have an Apple iPhone, right, or an Apple iPad, any of those kinds of things, he needed to register his company, because now he needs a lot more money, not just the money that people can give him. He needs to register his company on the stock market. And what that means is, if we log into the stock market, there's a place where you can go. Alexander gave him 5 Rand. Well done. Yes, Anotida, about the same thing. It's about the same thing, right? So if you go on the stock market, if you go to your Google and you search for the JSE, you can actually see a list of all the types of companies that you can possibly buy stocks for. So let's say, for instance, you go to the JSE and you want to buy a share in Apple, like maybe 1% of Apple. It's going to cost you a lot of money because Apple is very expensive. And they'll tell you, okay, to buy 1% of shares in Apple, you would have to give us $2,000 US. $2,000 US, right? And you will give them $2,000 US. And I know the story sounds like it has nothing to do with probability, but I'm getting there. Okay, you will give them $2,000 US, and they will give you stocks or shares in a company. Correct, Sisipo. Correct, like stock brokering, right? Exactly. So you will give them that money, and then now you are part owner of Apple. You are part owner of Apple. Now, here's the thing. Apple is a company, and company earns profit, and sometimes they make a loss, right? They don't always make a profit. Sometimes they make a loss. Now, in order for us to see whether our company is going to make a profit or a loss, we look at all other aspects of the things that are happening. And now let's say, for instance, because we know that Apple products are manufactured in China. Now, let me ask this question. If the factories in China go on strike, what do you guys think is going to happen to your Apple stocks? Will they make a profit or will they make a loss? Good. They will make a loss, right? Good. We know this, right? Or we can predict this, right? When we hear that Chinese companies are making or are going on strike, and we know, ooh, Apple products are made in China, we can predict that Apple stock prices are going to go down. They're going to make a loss, which means your $2,000 that you gave them isn't actually $2,000 anymore. Now it's going to be something like $1,400. So you've also lost money. Okay. You've also lost money because the stock has gone down. Now, what they do during the stock market, people like stockbrokers and actuarial scientists, if you've ever heard of an actuarial scientist, this is what they do. They make calculated predictions. And the way they make these calculated predictions is by calculating for the probability of things. Okay, what is the probability that something is going to happen based on the information we have? Okay, give me a thumbs up if this makes sense. Probability is calculated predictions. Are we all okay with this? Give me a thumbs up, peeps. Okay, Amogelang, where did I lose you? Hi, Entle.
Ma'am, you lost me when like you were explaining about Apple, like I completely blanked out.
Okay.
Because I knew, like I understood from JSE to like stock markets and all that. And then now I was talking about Apple and Steve Jobs, and then you lost me, and then we're back to probability. And
Okay,
then,
all right,
know.
Okay, let's make this easy. Enke, if you are an owner of a Checkers, right? Let's say you own a Checkers stores, okay? If your supplier, or if the Checkers truck gets into an accident, are you gonna have food to sell to people in your store?
No.
No. So our prediction there is that your company on that day that your truck has gotten into an accident, your company is going to make a loss. Am I making sense?
Yes.
Okay. Now, let's say, for instance, you own this Checkers and then you get a deal to sell Prime. You know Logan Paul and KSI's Prime?
Yeah.
What is your prediction? Are you going to make a profit or a loss?
I'm feeling like it's a profit. I don't know.
Of course you're going to make a profit. Okay. The reason I'm saying you're going to make a profit is because many kids want to buy Prime. So your company is definitely going to make money. Am I making sense? So yes, the prediction is that you're going to make a profit. So when KSI and Logan Paul reach out to you and they're like, would you like to sell Prime in your store? You need to think to yourself, well, the probability of me making a profit is high. So yes, I want to sell Prime. Okay.
Oh, okay.
Does that make sense?
Yes, ma'am. Thank you.
Okay, you're very welcome. Good question. I think some people were also kind of, okay. And yes, guys, remember, I know I don't appreciate kids buying Prime. I know I have my own reservations about Prime. It's not okay for kids. The caffeine content is too high for kids, but that's another story for another day. All right. So the probability, right? Probability, guys, the probability of us doing anything is a calculated prediction. Now, this is where this comes in. The idea of theoretical probability. Theoretical probability. Now, here's another easy question. Can we really ever know what's going to happen in the future? Yes or no? No. Good. Okay. Good. We don't actually know what's going to happen. Okay. Some killer says 50%. No, it's not 50%. We can never really know what's going to happen in the future. And that is why we're saying that whatever it is that's going to happen, is a calculated prediction. It's not actually going to happen. We don't know this for a fact. Okay. We don't know this for a fact. That's why the probability that we're going to be calculating for is theoretical, and I don't believe in profits. So no, even profits is a whole other story. Aiden, don't get us started. Don't get us started. All right. So when we calculate for the probability of something, we are looking at whether this thing, what is the likelihood of this thing happening? Now, let's think about this. I'm going to come back to these definitions in just a bit, but for now, there are 3 different ways that we can possibly calculate for probability. Just like somebody said in the chat, I can't remember, there's like a 50% chance, or there's a 70% chance of something happening. We can either write that as a 50% chance, 70%. We can write it out in percentage, or we can write it as one number over another, or we can write it as a decimal, as 0, comma something. And when we have probability, you can only write numbers between 0 and 1. Okay, now let's look at this idea of using any number between 0 and 1. Now, let me ask a question like this. Let's just say this is impossible or unlikely. Unlikely. What is the probability that ma'am will turn, or teacher Coco will turn into a unicorn tomorrow? And I'm watching you guys. What is the probability that I will turn into a unicorn tomorrow? Who said 100? Somebody said 100. Who are you? Keegan, I got my eye on you. Princess, good. It's 0%, right? So there's a 0% chance that, that I will turn into a unicorn tomorrow, right? Now, let's say, what is the likelihood that teacher Coco is female? What is the percentage? The likelihood that teacher Coco is female? Good, it's 100%. So we're going to have 100% over here, or we're going to have just the one here, for very possible or likely, 100% likely. Okay, likely. Now, what is the probability that it will rain tomorrow? Thanks, Anutita. 98% human. Thanks. What is the probability that it will rain tomorrow? We don't know. It's either gonna rain or it's not gonna rain. So we'll say that that's 50%, right? And that is neither likely or unlikely, equally likely and unlikely. Okay, equally likely or unlikely. Okay, so we're looking at the idea of any of these things actually happening, right? This can also be a half. It's 50-50, so it's a half. Exactly, Samkelo. Because of the wind, it's not make sure, right? We don't know exactly what's going to happen. Now, all of these things that we've said over here are predictions. They are calculated predictions. Okay. What if, guys, we're not 100% sure that I won't wake up tomorrow a unicorn. We don't know. It's a calculated prediction based on the evidence. Okay. We are thinking about the probability here of anything possibly happening. Now, I want you guys to have a look at the following possibilities over here. Okay, it says, say whether the following events are likely, unlikely, equally likely, and unlikely, almost never, or very likely to happen. Okay, I want you guys to choose. When you're done, pop your favorite emoji in the chat while I speak to Shaden. Hi, Shaden.
Hi, how are you?
Hi, sweetie. I'm good. How are you?
I'm good, thanks. Ma'am, I just want to ask basically what you like, if you would like, what you're trying to say is now, is basically we will be calculating for something that we maybe not really sure about, or we're sure about.
Well, there's nothing that we can be sure about. Okay, we don't really know what's going to happen in the future. So all probability is just, it's a calculated prediction. We're saying, based on the evidence we have, this is what we think is going to happen.
Okay.
Okay.
Okay. Thank you.
All right. Am I making sense?
Making sense.
Good. All right, my sweetie. Excellent. Good question. Mawande, what's up?
Hi, ma'am. How are you?
Hello, I'm good. How are you?
I'm good, ma'am. So, ma'am, these questions, right, they kind of
Yes.
depend on where I am, right? Because Johannesburg right now, it doesn't look like there's a chance it's going to rain. So that's what I think.
Okay, but think about the country we live in, right? Have we ever had a tsunami? And where do tsunamis normally occur?
Somewhere by like the Ring of Fire thing. So Japan and Indonesia.
Ooh, remember, tsunamis need waves.
Sea, I mean.
Yes. We're going to need a sea coast. So what is the probability of a tsunami happening in Joburg? Remember, Joburg is land.
Unlikely. It's unlikely.
It's very unlikely. Do you understand?
No, ma'am, yeah, no, I do understand, but like the rainfall thing or like fog thing, like weather, where I am or there might be different weather conditions.
Of course, that's why I'm asking everybody to tell me based on where they are, what the chance of rain tomorrow is. Okay.
Thank you.
So it will be based on where in the country you are.
All right.
Okay.
Thank you.
All right. Good. Jessica, what's up, my sweetie?
Hi, ma'am.
Hi, my sweetie. What's up?
If they ask you a question in the test and they ask you a question if it's 50-50 on a dice or something, and it's wrong, how do you, if they give you an impossible question to answer, how do you answer it then?
You're just going to say the probability is 0. Okay. Like, for instance, if they say, let's say they say you roll a dice and you get a 2 and a 3. Can we get a 2 and a 3 at the same time on a dice?
No, ma'am.
No. So the probability here is 0. Okay. The probability.
Okay, thank you, ma'am.
Okay. You're very welcome, my sweetie. But we're going to talk about that in a little bit more detail. Okay. All right. Okay. Let's see these kinds of questions here. All right. Depending on where you live, tell me, guys, what is a 90% chance of rain tomorrow? If you're, let me not say depending on where you live. If you're looking at the weather and the weather person says, there's a 90% of chance tomorrow. Is this likely, very likely, unlikely, equally unlikely, or likely? They've said 90%. Now think of where 90% would fall on this scale, right? It's likely, Depending, it doesn't really matter where in the country you are. It's very likely or likely that you're going to get rain, right? Very likely. We'll make this one likely. Here, we'll make this one unlikely. And we'll make this one very unlikely. All right. What about a tsunami in Joburg? Okay. Now, I understand where everybody's coming with when they say never. They say it's impossible. But like we said, unless it's things according to a certain situation, we can say very unlikely, but I don't think we can say never, ever, ever. I think we can say very unlikely, right? Unless we get one of those doomsday kind of tsunamis that take out the whole country. You never know. Maybe there'll be a tsunami in Joburg. We don't know. Okay. But mostly we can say almost never or very, very unlikely. Yes, like an apocalypse, something of those sorts.
Sorry, Teacher Coco.
Yes.
Refilio would like to take a screenshot of the scale above.
Oh, okay. Sure. Thanks, Teacher Nels. I'm just going to move up. Refilio, there you go. You can take a screenshot. Let me just remove those two things so those I don't confusing you. All right. What is the probability of either of us turning into a frog tomorrow? Probability likely. Alexander, are you going to turn into a frog anytime soon? Okay, I would say very unlikely. I don't know about the rest of you. If you guys feel froggy, then maybe you guys will turn into a frog. I think just by my biology, it's very unlikely that I would turn into a frog. Okay, so I would say unlikely. All right, what about throwing a dice and landing on an even number? What do you guys think? It's an equal, yes, I agree, Keegan. It's equal. You're either going to land on an odd number, so you're either going to land on 1, 3, or 5, or you're going to land on an even number, 2, 4, or 6. So it's a very close chance, right? So it's equally unlikely and likely. Equally likely and unlikely. Okay. unlikely. And then the very last question, throwing a dice and having it land on 1. Now you have to think about this. There are many options on a dice. Okay, there are many options, and 1 only shows up on one side. So I am kind of inclined to say unlikely. Okay, it is very possible. It is possible that you could land on 1, but I would say unlikely, because if I have to choose 1 and I still have 2, 3, 4, 5, and 6 to contend with, I'm already thinking, maybe not. The odds aren't really in my favor. Okay. All right. Let me take Rulani's question quickly before we continue. Hi, Rulani.
Hi, ma'am.
Hi, my sweetie. What's up?
Ma'am, I'm asking for question. For question D. For a dice that has 6 digits or 6 values, can you also sometimes just say like half of 6 because, or add a value to the actual answer?
Good. Yes, we can say 50-50. Okay, 50-50. And I'm going to explain when we put it into calculations why it's going to look a little bit different. Okay.
And for C, what if I said almost never, because you can't turn into
Yeah, that's perfectly fine. That's perfectly fine. I don't think it's very, very, very unlikely that you're going to turn into a frog. Okay, so you can say almost never. That almost is very important. Okay. Good stuff. Oratile? Hi, Oratile.
Hi, Teacher Coco.
Hi, my sweetie. What's up?
Ma'am, I wanted to ask if you wrote for number C, turning into a frog almost never, is it correct?
For turning into almost never. Yes, that is correct. We can write that.
Thank you, ma'am.
Okay, you're very welcome, my sweetie. All right. Okay, guys. So let's go back to those definitions that we'd been looking at a little bit earlier on. Right. Let's look at these definitions that we've got over here. Now, if you are taking notes, this is going to be one of the sections that you're going to need to take notes for. Okay, because what we're about to talk about over here is very, very important. Okay. All right. Sure, I'm sorry, Alexander, but knowing you, you're probably going to be super ready. Okay. All right. So let's talk about a sample space. Now, let's say, for instance, we want to see if we roll a dice, what's going to happen. If we roll a dice, right? We know that a dice has how many sides, guys? Let me know. How many sides does a dice have? Good. Good. We all know this. A dice has 6 sides. So a sample space for rolling a dice is going to be all the different possibilities that we can get. All right. So the sample space here for rolling a dice is going to be either we're going to be able to roll a 1, a 2, a 3, a 4, a 5, and a 6. Okay. Those are the only options that I get, right? Now, the experiment, right? The experiment is what I actually do. What I actually do here in the experiment is rolling a dice. Roll a dice. I know that, Alexander, I know if you play like Dungeons and Dragons, you can get dice with like 15 different sides. I know those kinds of things exist, but we're going to focus on your run-of-the-mill die here. Okay, we're not going to go into any funny dice with like 6, 10 or 12 or 15 sides, just a normal dice, right? So our experiment is what we actually do, right? We either roll a dice or pick a card, or we flip a coin, something along these lines. Now, depending on how the experiment goes, the outcome is what we're going to theorize. Because we're not sure, we haven't rolled a dice as yet. Okay, we haven't rolled a dice as yet. We're going to think of the outcome. The outcome is what will happen, right? What will happen? We don't know yet what will happen. Correct. Good and clear. Yes, the outcome is the result. The outcome is what will happen or the result. Remember, at this point, guys, We're only thinking about rolling a dice. We haven't actually rolled a dice as yet. We're just thinking about what would happen if we were to roll a dice. Now we know we have 6 options, 6 things that could possibly happen if we rolled a dice. Okay, the experiment is going to be for us to actually roll the dice. The outcome is actually what's going to happen. And then the probability, okay, the probability of these things happening is what we predict. The probability is our prediction. Okay, so I'm going to explain. Now, if I say to you, what is the probability that I would throw a 4? The probability of rolling a 4. Of rolling a 4. Now, I know that on my dice, let me try and draw a quick dice. Okay, 1, 2, 3. We're going to pretend that this is how a dice actually is. This isn't how a dice is. Okay, there's only 1 4 on my dice. There's only 1 4. There's one side that has a 4 on it. So the probability of me rolling a 4 will be 1 over the number of probabilities that I have, the number of outcomes that I possibly can get. How many different results can I get? I can get 6 different results. 6 different results. How many of those results would actually give me a 4? Only one of them would give me a 4. And that is why my probability is 1 over 6. Hi, Shaden.
Ma'am, I just wanted to ask, do you have another word for prediction, like another term that we can use, that we can try and understand maybe?
It's like, let's say, a calculated guess or a chance. Yes, the chances of something happening. Or, but I'm saying this, it is a calculated guess. So we're not just going to say it's a guess, it's a calculated one. Okay.
Okay.
All right, my sweetie. Okay. All right, good. So these things are very important, or a hypothesis, correct, Elisha? Okay, but guys, you guys are always judging my drawing. Okay. Okay, so when we think about all of these things that we're doing, guys, they are only theoretical because we didn't actually do the thing. We didn't actually throw the dice. We didn't actually throw it. So theoretically means what would happen if? What would happen if we threw a dice? Not that we actually did it. If we actually did it, that would be the outcome. That would be the result. The theoretical probability is what happens if we throw a dice. If, let's say, for instance, we throw the dice and we actually land on 4. If we land on 4, then our prediction was actually wrong because we actually 100% landed on 4. But because we have 6 options, before we throw the dice, there's only a 1 in 6 chance that we will actually land in 4. Okay, I'm going to do the example again, and it's going to make sense just now. Siamtanda, what's up?
Ma'am, I wanted to ask if there's not a formula for this thing or...
Not really, and I'm going to show you why I'm saying that, okay? Because there are certain steps that we need to take in order to understand. Okay, I'll show you just now. We're going to do these examples over here and I'll show you. Okay.
All right.
All right. Correct. And we're going to talk about Venn diagrams on Wednesday. Okay, Buche, I'm going to take a question just now. Okay, I'm going to take a question just now, but I want us to think about this. Okay, it says here, for each of these events, give the theoretical probability that the given outcome would occur. Now it says, throwing a dice and having it land on 2. The first thing that we need to think about is our sample space. Now, this is a dice. How many sides do we have to a dice? 6, correct. 1, 2, 3, 4, 5, 6. Now, when it says having it land on 2, we need to go back to our sample space and have a look. How many 2s do we have? How many 2s do we have? Exactly 1. We only have 1, 2. So the probability of us throwing a dice and landing on 2 is 1 out of our 6. Okay. See, Amtanda, this is why we do not have a particular formula. Well, there is a formula, but then it just tells us the same thing that we're going to have over here. Right. So, okay, let me teach the formula because I feel like some of your teachers are going to teach it, but it's not 100% necessary all the time. Okay, so we're going to say the probability of an event taking place is going to equal to the number of events that we want, okay, over the number of our sample space. Okay, now our event is going to be landing on 2. How many times can we land on 2? We can land on 2 once. And how many numbers do we have in our sample space? How many times can we possibly land on a number? 6 times. Okay, for those of you who are lost, I'm going to need you to put your hand up, okay, and ask a question. All right, now let's think about this again. Now, this next question says, throwing a dice and having it land on an even number. Now, let's see. The probability of us landing on an even number is going to be, how many even numbers do I have? I've got a 2 and a 4 and a 6. Those are 3 numbers, just 3 numbers. So the probability of me landing on an even number is 3 out of how many options do I have? I have 6 options, so 3 out of 6. Okay, but we can simplify that to 1 over 2, correct? 1 over 2. All right, Princess, what's up?
Hello.
Yes, Keegan.
Hello, ma'am.
Hello, my sweetie.
Ma'am, can you hear me?
Yes, I can.
Okay. Ma'am, okay, so like here I'm following and all that, right? But then like to my textbook on like last week, ma'am gave us like homework, right? And then it's like what you call it? The exercise is like a 6-sided die is thrown. Determine the probability of 1, 2, 3, and 4, right? So 1 says throwing a 6. So then like how am I gonna get it like that? And then 2 is like throwing a 3 or a 4. Number 3 is throwing an even number. Number 4 is not throwing a 2. How do we solve it like if it's like that?
Okay. I'm about to show that not to throw a 6. And then the other one was an even number. Okay, so we've just done even, Princess. Okay. And I'm going to do the rest with the rest of the class. Thanks for that. We're going to use these examples. Okay. Is that okay, Princess? Just follow along as we go.
Yes, ma'am.
Right. All right, my sweetie. Good stuff. All right. Okay. So let's finish up here quickly. Okay. I want us to do this, and then we're going to use Princess's examples quickly to get to this answer. All right. So we've just thrown a dice, guys. And what is the probability of it landing on a 7? It's a 6-sided die. It's got 6 sides. So what is the probability of this dice landing on 7? The probability is 0 because 7 doesn't exist in my sample space. So the probability of me landing on a 7 is 0. It's not even unlikely. In this case, we can say almost never. Okay, we can say impossible. 0 over 6 or just 0. Okay, now I want us, I wonder how Sway? Make it make sense. Okay. Witchcraft. Okay. All right. So let's take Princess's example over here. So Princess says, what is the probability that our dice will land on a 3 or a 4? Let's look at our sample space. Where do we have a 3 and a 4? Let's see. 3 and a 4. How many options do we have for 3 and 4? That is 2. So the number of experiments we can run here is 2 over how many options do we have altogether? Correct. Over 6. Right. Good. Over 6. Now we still need to simplify this, which means that our answer then comes out as 1 over 3. Now, we don't have to stop there. We don't have to stop there. We can then write this as a decimal. You can punch this into your calculator as a decimal, and you can write it as 0, I know it's going to be 3 recurring, so we're just going to put a little dot there for 0,3 recurring. I can also take this half and I can also rewrite it as 0,5 because I can express this in 3 ways. I can either express it as a fraction or as a decimal. What other way can I express these probabilities as? As a percentage, good. So I know that this is going to come out as 50%. I can rewrite it as 50%, or I can rewrite this as 33,3 recurring percent. Okay, so you can write them either way. We can write them either way. Now, okay, Zipozonke, do you have a question for me, Maswidi?
Please explain the formula.
What am I explaining?
The formula P is equal to N
Okay,
E
so,
over
all
N.
right. Zipozonke, don't go away. Let's do this example together. All right, what is the probability? Do you see how I'm using the P for probability here? The probability that I will roll a 1, right? Now, this N tells me how many times I can run the experiment. What is my experiment? To roll a what?
Dice.
Yes, to roll a dice and get a 1. So how many times am I going to be able to do that? Once, right? So the number of events that can happen is once, because I can only roll a dice once, one time. Over how many times can I, what different options can I get if I roll my dice?
There's 6 options.
6 different options. So I write 1 over 6. Okay. Am I making sense?
Yeah.
Okay.
Yeah.
Good stuff. Good stuff. All right. Okay. So let's talk about this last example that Princess has given us here. What is the probability? What is the probability that I do not roll a 2? Now, if I don't roll a 2, how many different options do I have then? What other options do I have? I have a 1, or a 3, or a 5, or a 6, or a 4. Sorry, I forgot 4. A 1, a 3, a 4, a 5, or a 6. So the probability of me rolling anything except a 2 is going to be 5 over 6. Okay. All right, give me a thumbs up if the stuff makes sense. Is the probability of something happening making sense? Okay, Nicole, because how many numbers do we have that are not 2? How many numbers do we have that are not 2? Good, that's why we have 5 out of the 6 options. Okay. Okay, so the chance of us actually getting that number is very likely. Okay, so now I'm going to ask this question again. These predictions that we've made, are they actually, is this something that's actually happened? No, they're not things that have happened. They haven't actually happened. Good, they are estimates, they are predictions, they are calculated guesses. They are guesses. So that's why we call it a theoretical probability. We call it a theoretical probability because we are only guessing at the probability of what will happen. We're not actually saying it's happened. We are saying that this is what we think would happen if. Okay. And that's why we call it a theoretical probability. All right, give me a thumbs up if that makes sense to you. It is a theoretical probability, not actually what has happened. Good. I need to make sure you guys understand this, because when we start doing relative frequency, I need you guys to understand what this means, what probability or theoretical probability means. So if I've still lost you, please feel free to put your answer or a question in the chat so that we can discuss. I'm more than happy to help you guys again. All right. I want you guys to answer C or D and E in the question for me. Now, I need to ask you guys, let's think about this. Flipping a coin. I still need to first look at my sample space, guys. If I flip a coin, what are my two options on a coin? Not two, not two. Those are not my options. Good, Mawande. My options are not two. My options are either heads or tails. Those are my two options. That is my sample space. Okay, that is my sample space. And I want you guys to use that to answer questions D and E. All right, Sinako, how's it going?
Ma'am, sorry, ma'am, I pressed by mistake.
No, no worries. Are you understanding everything that's happening though?
Yes, ma'am.
Good. Okay, excellent. All right, Sinogusha, what's up, my sweetie?
Hi, ma'am.
Hi, my sweetie, what's up?
I'm good. Ma'am, can I please do another example because I'm lost. I don't understand.
Okay, cool. All right, my sweetie. Okay, let's look at this flipping a coin example, right? If I flip a coin and I wanted to land on heads, what is the probability that I will get heads? How many times can I get heads on a coin?
6 times.
It's a coin. How many sides does a coin have?
2.
2 sides, right? It's either heads or tails. So the probability of me landing on heads, how many times can I land on heads? Just
1 time.
Once, right? Once out of how many sides?
6.
No, it's a coin, not a dice.
Sorry,
Coin.
2.
2, 1/2. Okay, so it's very important, Sinogukle, that you remember to look for the sample space first. Okay.
Yes, ma'am.
We need to establish the sample space so that we don't make a mistake. Okay. In this case, because we're flipping a coin, that is our sample space. Our sample space is the sides of a coin. Okay. And we only have 2 options on a coin, heads or tails. Those are 2 options.
Yes, ma'am.
Okay.
Thank you.
You're very welcome, my sweetie. All right. Rulani, what's up?
Hello, ma'am. I'm
I'm
just asking if you can repeat the answer for when you said that P is not equal to 2 based with the dice.
Okay, so let's look at our sample space here, right? Which one of these numbers of the dice, which one of them are not 2?
We have 1, 3, 4, 5, and 6.
How many of those are there? Count them.
There are
How many
5.
are there? There are 5 of them. 5 out of how many options?
5 out of 6 options on the dice.
Correct. So that's why we wrote 5 out of 6. Okay. Am I making sense?
Yes, ma'am.
Good. All right. I hope that helped to clarify some things. Sianda, what's up?
Hi, ma'am. I would like to ask, ma'am, what happens when when it lands on neither?
You mean the coin?
Yes, ma'am.
Okay. In this particular sense, because we are theorizing, remember, we're making a calculated guess. What is the chances that your coin, if you are guessing that it's going to land on its side, like standing up straight like that? What are the chances?
Ma'am?
If you had to guess, what are the chances that your coin will land like this, if this is the floor? If you had to take a calculated guess, what do you think would be the chance that your coin would land like that?
Ma'am, it's 0.000001.
Yeah,
by me.
That's it. 0.000001. That's it. Because it possibly could, let's say for instance, there's a crack on the floor and it lands in the crack and it stands like this. Sure. But I mean, if we're really going to think about it, we can say that the probability of it landing on its side is 0. Okay.
Oh, thank you, ma'am.
Okay. You're very welcome. All right, good question, by the way. So we know that the probability of a coin landing on its side is probably 0, okay, or something very close to 0. Okay, Mfundo says 0/2, and I'm going to agree with Mfundo on this one because we want to make sure that we're expressing this correctly. What is the probability of this landing on its side? Probably 0/2 or 0,0000001/2. Okay. Okay, and I'm going to remind Michael not to spam the chat in Watobe YouTube. Okay, remember not to spam the chat. We've spoken about that. You answer the question once and then you let it go. All right. All right, Mawande.
Ma'am, I have kind of a stupid question, but
no
it's still
such
related
thing.
to the. All right.
No
so
such thing. What's up?
A coin is basically a super flat cylinder. So that means it has like 3 sides, right? So
yeah.
So does that mean there's like actually 3 sides or 2 sides?
You know, like when you put it like that, we could technically say that there are 3 sides, right? And you're going to win that argument on a technicality, Mawande. You will. Okay, because technically we can say that the sample space for a coin is actually heads, tails, and the side. We could say that, right? We could say that because it's a cylinder, right? You're absolutely correct, but you have to then acknowledge, Mawande, that because the cylinder side is so thin, the chances of you flipping a coin and it landing on its side is going to be much less than it would be for these other 2. Do you agree with me?
No, definitely I agree, man.
Yeah. So because the probability is so small, it's so minuscule, in any instance, we could almost negate it. We could say that it's not going to be a thing. Okay. Right. Am I making sense?
No, it makes sense. It's just like technicality.
All right.
Thought about it, so.
No, absolutely. And remember, when we look at a sample space, we're looking at the options that we would possibly have. Each of the outcomes in our sample space have an equal chance of happening.
Okay, or the highest chance.
Yes, they all have an equal chance of happening. I have just as equal a chance of getting heads as I do of getting tails. Same with a dice, right?
Oh, okay.
I have just as much a chance of getting a 1 or a 2 or a 3 or a 4. So we're looking at things that have even odds or the same amount of odds. Okay.
All right. Thank you, ma'am.
You're very welcome. Good question, by the way. Sure. No, like you're making me be very philosophical and it's not okay. Okay, yeah, it's making us think very well. Okay, now let's talk a little bit about relative frequency in the 1 minute that we have. Okay, now in the next lesson on Wednesday, I'm going to need you guys to bring a coin, preferably a 5 Rand coin or a 2 Rand coin. You can choose which one you want. Or any coin, as long as it's a big coin, bring a coin. Make sure it's not a rigged coin or anything of the sort, right? But before we continue, no 10-cent coins, they're too small. Maybe a 50-cent coin you can get away with. A 200 Rand coin, sure, Ntanganipo. 5 cents, I haven't seen a 5-cent coin in forever. 20 cents is a bit too small. 5 cents is All right, so bring a coin, guys. That's the whole idea. Bring a coin. Now, I'm going to ask you guys this question. If I flip a coin, right? If I flip a coin, I have 2 options. My sample space then tells me that I have heads or tails. Thank you, Teacher Nels. That's what I was going to ask for in just a second. Please answer the pace poll. I have heads or tails. Now, guys, what happens if I flip a coin? What happens if I flip a coin 50 times? What are my options? What are my options? Do my options even change? Good. My sample space, even if I flip the coin 50 times, my options are still going to be heads or tails. It's just that it's going to be heads or tails 50 times. times 50. Nothing has changed. Okay, so we're going to look at what happens when we do something frequently, when we do it frequently, when we look at the relative frequency. Now, we're going to then take the theoretical frequency and the relative frequency, and we're going to put them together. Next time, we are not only going to be predicting or making calculated guesses, we are actually going to flip coins and we're going to see what happens.